Hello and welcome to this follow-up video on equation loops where we will look at more advanced questions. If you haven't seen the first video on equation loops, then I recommend you do so before watching this. As a quick reminder, the equation loop method involves 4 steps: target, list, choose and solve. In this video, we see how equation loops are applied to multi-step equation questions, ones that involve at least 2 equations to be used, one loop for each equation. We approach the question as normal by finding the target from the question and listing the variables. But we notice that we don't have an equation that finds the target with the variables from the question. We choose an equation that uses the variables we do know from the question. We solve this equation loop, and this gives us the missing variable that we need to solve the first loop. We can now solve the first equation loop because we completed the list of variables using the second. Whilst I presented a simple question to illustrate how using 2 loops works, let's see how this works for real GCSE exam questions. In this question, our target is the distance fallen by the apple, s, and their variables are time, t, initial velocity, u, and acceleration due to gravity, a. The equation we need to find the distance is v squared take away u squared equals 2 times a times s, which I've rearranged into a far more useful form here. As you can see, this equation includes the target, but one of the other variables is not included in the question and isn't on our list: the final velocity on impact with the ground, v. We need to use a second equation loop that makes the final speed v the target using our variables list. We use this one here, which is a rearranged version of a equals delta v over t. We know the 3 variables in this equation loop that helps us solve for the target v. Once we know v, we substitute this back into the first equation loop, and now because we know all the variables, we solve for the distance to the ground s. We're not done yet, because to obtain the 6th mark in this question, we need to present our answer to the same number of significant figures as the ones we are provided with in the question. In this question, the maximum number of significant figures is 2, so our answer cannot be higher than 2 significant figures. Our answer of 1.225 metres becomes 1.2 metres when presented to 2 significant figures. This is our target from the question, and we have completed the equation loop with the help of a second loop. Let's look at a second question, and this one is interesting because there are 2 possible paths to take to find the target, the current I. Electricity has a lot of equations, and I've chosen this path to solve the question. I am going to use charge Q equals current I times time t to get my target. The problem here is that I only know the time t and I do not know the charge q. I make a second loop that makes the charge q the target. I use the equation energy E equals charge q times potential difference V. I use this equation because I want to find q and I already know E and V. Now I've solved my second loop to get q, and I go back to my original loop to solve for current I. We check the resolution of our numbers in the question and note the maximum significant figures is 2, so our answer cannot be higher than 2 significant figures. 25 amps is the solution to the equation loop, and we have found our target. I mentioned that there were 2 possible paths to take to find the answer. I chose Q equals I times T, but I could have opted for power P equals current I times potential difference V. I would have then been required to use a second loop to calculate power using energy E and time t. Both paths lead to the same answer of 25 amps. Try it for yourself. So in some physics questions, it is possible to take 2 paths to arrive at the answer, but in both paths, a second loop is required. This is pretty advanced work, but these questions are often worth 5 or 6 marks, and they can really help raise your marks and your grades if you commit to learning the equation loop methods and practicing it. Good luck with it all, and thank you for watching.